Hello and welcome to the continuation of the Unleashing SystemVerilog and UVM video series. My name is James Chang. I'm a senior staff instructor at Synopsys. In this video, I'll be showing you the power of the UVM factory. When someone uses the term factory, what do they mean? Typically, we think of a factory as a place where something is made. A factory is also capable of producing an updated version of the product. UVM has such a mechanism. It is a class called UVM Factory. To access the UVM Factory, you must import the UVM package. The UVM Factory has two registries built in, a class type registry and an override registry. Each user class is registered into the class type registry upon creation. Then, during simulation, the UVM Factory is used to construct the Testbench objects. How does this work? What's the override registry for? Why do we want to do this? To understand why we bother, let's start with a typical SystemVerilog testbench. At the very top of the testbench class structure is the test class. Within the test class, one will create an object of a class that's capable of interacting with the device under test. We typically call this class an environment. When constructing this object, one would also set its identity with the instance name and its logical parent. In this example, the instance name is env, and the parent of the environment object is the test. If we look at the environment class will then construct its own children components and assign a unique identity to each. Within the environment, each agent is responsible for interacting with one interface of the device under test. The scoreboard and coverage will take care of verifying the correctness of the device under test output and capture the result of coverage. Similarly, each agent would also construct its own children. Along the way, a unique identity is established for each object. For example, if the test is called UVM Desktop, then the path to the input agent is uvmdesktop.env.i_AGT. Once the testbench structure is established, our focus shifts to stimulus generation. For stimulus generation, one will first create a transaction class with random variables and the associated constraints. Then generate a stream of random transactions. In UVM, we call this a sequence. The final step is to store the stimulus generation in the test by using the sequencer to pass the transaction to the driver. This works. It is simple and straightforward. The problem is that it is too restrictive. When you use the constructor new to create an object, you're stuck with that type of object. In verification, it is highly desirable to be able to change the type of object being constructed without having to modify the existing code. Let's take a simple example. What if you want to run a new test with a different constraint? If you use the constructor new to create the object, you will need to write another sequence applying the new constraint class and another test to execute the new sequence. Wouldn't it be nice to just write the new constraint transaction class, then override the original definition with a new definition of the class with either a runtime switch or a simple override command in the test? This can be accomplished when you enable the UVM Factory override mechanism. The process only requires a few minor tweaks to the code. You just need to register every class you create into the UVM Factory, then use the factory to construct the desired object. Let's go back to the transaction class. First, let's bring UVM class into play. The base class of transaction in UVM is UVM sequence item class. Then, register the class into the UVM Factory with the UVM object util macro. Similarly, let's convert the sequence class to UVM compliant by extending from the UVM sequence base class. The UVM sequence base class will create a handle of the transaction class for you, so you don't need to create the transaction handle yourself. And just like the transaction class, register the sequence class into the UVM Factory with the UVM object utils. Once the class has been registered into the UVM Factory, you can then use the factory to create the object. Instead of calling the objects constructed new, one will use the class type register into the factory to create the object. With only a few lines of minor code changes, we're now able to use a runtime switch to tell the UVM factory to construct a different type of object without writing another sequence and another test. The only new code required is a class with a modified constraint register into the factory. This UVM runtime switch populates the override registry with a reference from the first argument to the second argument. When the UVM factory is used to construct the object, the UVM factory will check the override registry. If override registry is populated, the UVM factory will construct an object of the override type. With a simple runtime switch, you can now modify the definition of any transaction in your test without writing yet another sequence, yet another test. If needed, you can embed the override into a test. The structural component classes are also registered into the UVM factory. The difference is that the macro for the structural class is called UVM component utils, and the structural classes must have a parent argument in the constructor. For the structural component classes, UVM requires that a component object be created in the predefined build phase. With this in place, you can override any component in your test bench with a derived class. In summary, UVM factory is one of 4 UVM service mechanisms that you get when you import the UVM package. The UVM factory mechanism is simple to implement and results in reduced coding effort and enhanced code reuse. This is the power of UVM. So where should you go from here? This is how you can pace your journey into the SystemVerilog and UVM world. First, build a solid foundation in SystemVerilog. Then become familiar with the UVM concepts. Finally, pick up debugging techniques from your coworkers and friends. Synopsys can help you in building a solid foundation with hands-on training. For verification, we have workshops for SystemVerilog Testbench, Assertions, and UVM. In North America, our full-time instructors have over 60 years of industry experience in design, verification, training, and participates in IEEE standard committees. We can also customize our offerings for your needs. For more information and to register for classes, please visit this following website. This video is part of the series designed to give you an overview of what SystemVerilog and UVM are all about. Don't forget to watch the rest of the series. We are planning to release more videos in the coming month. Please give us your feedbacks and let us know what else you would like to learn in verification languages and methodologies. Thank you for watching.